Hi, everyone. Thank you for joining us. Today, we are part of the IEEE graduate student chapter here at UT. And today we have a special guest with us, Fawzi Behmann. He's the regional director of IEEE ComSoc North America. A little bit about our speaker. Fawzi is a visionary, innovative thought leader, results-driven, and author with a unique blend of business, marketing, and technology skills. He specializes in communications, networking, disruptive technologies such as IoT, AI, 5G, in developing smart eco solutions in key markets such as smart homes, smart energy, public safety, etc. Fawzi has held a variety of leadership positions with Teleglobe International Career, Nortel Network Systems, Motorola, Freescale Semiconductor. He also founded the Telnet Management Consulting firm and has co-authored Collaborative IoT by Wiley. Fawzi volunteered at IEEE and currently he is the IEEE WCNC 2022 Chair, ComSoc North America Regional Director, and BOG member. Fawzi holds an MBA, Master's in Computer Science, Bachelor in Science with honors in Mathematics with distinction. Over to Fawzi.
Thank you very much, Rachel, and good evening, everyone. I'm very happy to be with you. And certainly we're still at a very difficult time with the pandemic around us, but yet it generated a lot of interesting opportunities and innovation for getting together and in a different fashion. So I'm happy to share with you at least my thoughts and ideas and some of my personal experience, hoping that it will inspire you and make you more interesting, more passionate, more aware of what is going on, and be able, hopefully, to capture some of the ideas that you can put it in practice. And that's essentially the title of the talk tonight is certainly the time we're living in. Technology has a great influence. And if you add that to it, the business side of it and the marketing approach, well, you have really greater impact, greater penetrations. And that's in general generate opportunities for everyone, and especially you, the grad students, in areas of research and innovations and entrepreneurial activities and so on. And that's essentially what I tried to put a few slides to hopefully at the end will inspire you. So first of all, I wanted to give, as Rachel mentioned, she is head of the grad students and for UT here in Austin as a part of Central Texas section of IEEE. I'm also chair of several chapters, and namely the Communication Society chapter, computer, signal processing, and engineering biomedical, and lastly the consumer technology chapter. These are about 4 chapters. They have a lot of things in common, frankly. And I designed it especially to put it in a circle, indicating that these are all elements and drivers of technologies. When you put them together, you generate really an advanced, powerful, intelligent type of solutions. So think of it that way, that these technologies and being exposed to different society chapters of IEEE will bring you that type of information and approaches that could lead you to innovate and come up with interesting ideas that will help your community or help the place that you're working or teaching or studying. I also want to bring some greetings from overall. I talked here from Central Texas sections, which has somewhere around 4,000 members, but also I'm the director for North America for the Communication Society, and that's where we have about 10,000 members, and we have 93 chapters across 7 regions, all the way from for covering US as well as Canada, as you could see here from the names. But certainly we're all striving to stimulate the members and help promote activities for the chapter chairs as well as the members and the community, and organize things like regional chapter chair congress, which actually will working very actively on that. That will take place early December this year, covering the 95 chapters, as well as we have what's called distinguished lecture program, covering somewhere around 62 chapters worldwide, that we can tap on, as well as 29 distinguished lecturers. And I'm fortunate to be part of that list of both the recipient side as a chapter chair, but also giving in terms of distinguished lecture. We do have strategic initiatives and outreach program, and also we do offer exceptional service award to the outstanding members contribution. So let's go back now to the main topic and establish a high level type of agenda. And so, since I talk about the impact of technology, we wanted to understand a little bit what do we mean by advanced technology, and what's the trend? Where is this technology going, and how can we tap into it? And what will be the intersection between technology, business, and marketing? And by understanding that, and also look at the future ahead in terms of a roadmap or evolution, and some of the indication, as you all hear about everything is going to the edge for processing. Certainly, that's an area that we would like to touch on, and as you will see it through examples. And also, what do we mean by advanced technologies? And in other words, in fact, I put more focus on disruptive technologies. These are the technology that will have impact in all markets or areas of the market. And that would include things like cellular communication protocol, especially the advanced one, 5G, that started this year, as well as to be followed later on with 6G. Then, of course, we're all aware of IoT, how it is being deployed in many type of application, and of course the artificial intelligence and machine learning and deep learning and so on. And want to put all that together in terms of opportunities that could impact areas of interest. You may be interested in just carrying out various types of research, technical research, academic, pursue your whatever doctorate degree or postdoctorate degree, and so on. Or maybe you want to branch into becoming a startup or a small business, or contributing to a larger industry leaders, and contribute in terms of innovation collaborations. So these are the kind of things I want to cover in this talk tonight. So I want to put always at the front an image that say this would this be the goal? Would this be? I'm painting a picture of what's starting in 2020 and beyond, and as it really encompasses many things. In the bottom left corner, you will see here all types of cellular, wireless, as well as fiber optic technology that really building the backbone infrastructure for everything that we do. And as you can see, we have two axes: the vertical axis, which is more latency focused or dependent. So the higher you go up, the lower the latency is. And then the x-axis, you have deployment in terms of massive connectivities, such as massive IoT connectivities and so on, machine-to-machine connectivities. So that's really showing the expansion and coverage in multiple areas. So with the backbone infrastructure, you got the evolutions into remote access technology, architecture evolutions with 5G, and that bring us now sectors of activities. So on the low latency side, you have things like medical care, remote arm surgery, things of that sort, first responder. Then you have the throughput capacity with the transportations, autonomous vehicles, and so on. And then you have the entertainment and broadcast. You have the energy efficiency as you go down in terms of not as such highly critical in terms of latency, but in terms of connectivity overall, and smart energy, as well as logistics like fleet management and so on. All of these things are part of any kind of uh, social cultures of any kind of societies. And if you link that with openness in terms of interfaces, and you have the engagement of both in terms of clients or citizen or partners, then you are opening a whole innovative platform for bringing in much richer type of solutions, new classes of services, which will really add more value to the society and to the culture itself. But the overall aim is really principal things that we all need. We need safety, we need security, we need efficiency, we need equality across many areas in the cities we live in, public services, as well as in the lifestyle that we have, as well as the overall industry. So put that as a picture and picture yourself. Where do you want to play, and how do you want to make an impact, and what do you want to innovate and create? Whom do you want to work with, and things like that. So it's really a painting or a picture in terms of a vision for the future. It's starting actually this year because 5G has started this year. That's why I put it as Network 2020. But it is evolving, and you will start seeing for this remaining of this decade a lot of activities that's being carried and being implemented. So that's really an overall future vision. The question is that where are we today? And I try to put it in a simplified form, and these are actually all captured just for your information in a book that I co-author called the Collaborative IoT. And I'm saying that the if we look at all the companies around us from day one, and especially in this earlier part of this decade, companies all centered around services. So you have a lot of professional services, company like IBM and others, company that focus a lot on communications and networking and the edge of the network, the core of the network, and so on, and companies that are focused in the low end in terms of sensing activities and monitoring and data acquisition type of activities. These are all, frankly, are segmented, um, meaning that there are typically standalone type of activities. But yet, with the disruption of technology, it's really company becoming aware, especially starting with the IoT as a disruptive technology. It really shook every layer. So people start tightening the gaps between them, and companies in each area started collaborating with each other. So what you end up is really the stack of these layers. So now companies can work with others in terms of helping out, getting some sensors from one area, communicating the information to the network itself, and then getting the data out for processing and services to another area. And that's what resulted to what is called a point solutions. So what companies today is really focusing a lot in a single point type of solutions. Some companies really have multiple of point solutions, and very few companies have multiple point solution, which is really what the evolution is, going to more of a collaborative solutions, meaning that you are interpreting the information not just for acting and controlling and management of a given point, but really are looking at the cluster of points and information and sources, and making sense out of the data that you're getting it here at the that could be the edge of the network here, process it and provide some means and control going back to where implication that need or action that need to take place, as well as take it further to the next level for processing, as well as trend analysis and services, and getting more insightful information for direction. So that's really where I could see towards ecosystem smart solutions. I would easily say that there is not a single company really that can give you everything today as a single company. So that's where it is calling for collaborative collaborations among suppliers, and that's where the word ecosystem come into play, because that means not a single partner or a vendor can really produce all that, but it comes through a lot of collaboration. I took that further and saying, okay, so how do we capture, if I am in automotive, or if I am in energy management, or if I am smart homes, um, or educations and so on, how do we represent that approach that we are talking about? And this was really something also that I put in the book itself, which again, taking the same concept and really articulating on it, that there are three layers in terms of coming up with an ecosystem solutions. They're always dealing with sensing, you have to tap into something to extract information, whatever that is. And that information could come from a wearable, could come from your smartwatch, could come from sensors that they're putting in for heating or electricity, for example, or temperature or the environment, um, or how the car is behaving, the speed, and so on. All these are parameters that give you informations, and that information is really uh, sent to the next level through various types of different protocols, depending on the type of information that you are connected and the means of physical protocol, whether it is Zigbee or near field communication or Wi-Fi. But anyhow, it's bringing to the next level where you can do quite a bit of processing in real time and act on the information in real time. So I put here the edge computing for processing really at the edge, or edge AI, which is edge advanced in artificial intelligence, meaning that when empowered by next generation cellular, which is 6G, that edge compute will become fully involved or fully encompassed by the by artificial intelligence through multiple modules and so on. And so whatever you decide here, some information can go back, some information will go up, but in general, you can do quite a bit of machine learning and controls and data trending and big data and analysis coming at the service layer. So you always have the sensing, the computing side, as well as the data services and the big data at the end. So that's really something that encompasses what I call it ecosystem smart solutions for any market. Now we know that IoT crosses all markets, and IoT is really integral part now with the introduction of 5G. It's really empowered by 5G, but you could see now it will advance much higher in terms of growth market from one year to the next. So for to today is about 248 billion, and if you look by 2025, mid of this decade, we're reaching 1.5 trillion dollars. So that's a major, big, huge market. Looking at somewhere about 50 to 80 type of billion devices sort of being connected to the network worldwide across various types of vertical markets. If we look at the AI, that is really started strong, but still have a huge room for growth. Looking at the market of 7.1 billion by 2017, that's growing to 98 billion by 2023. So, and it has all these circles, the artificial intelligence assisting of what is taking place, replacing redundant behavior or processes by automating them, and then building up algorithm for machine learning of what has taken place so that you could produce it quicker, and then the deep learning really by looking at certain patterns and apply neural networks to come up with much more predictive approach and way of doing things. The third disruptive technology is really 5G, and that's really the future, at least for this decade and beyond. And this is a huge market. This is 13.2 trillion market by 2035. But as you could see here, the difference between 5G compared to all the other generation, first, second, third, and fourth, is that it enables and empower the building of ecosystem solutions. And I'll touch on that in more details. So, for example, that will maybe heard of precision farming or precision agriculture. And so I put down at least the market size by 2035 for the precision or precision agriculture, looking close to $400 billion. The construction and mining, about 1 trillion. Digitized educations, connected healthcare, rich mobile experience, smart manufacturing, intelligent retail, and so on. All of these are areas for you to think of, because not every person is really interested in all of them, but you may be inspired that one area I love agriculture because I don't know family and so on. So I would like to go back and help and come up with innovative solution for agriculture. Or I like educations. I'd like to come up with, especially in the pandemic, I'd like to come up with more innovative tools to make education and teaching and collaborations a lot easier and more interesting and more inspiring. Same thing, we've experienced a lot of new ways of doing things with the healthcare and containing the virus and so on. So whatever area inspire you, these are some areas I'm showing that it's a huge growth areas, and certainly it is an opportunity for to pursue. So how would these all tie together? And as you are going about which area to go through, don't worry about it, because again, they're all tied like a glue with 5G. So, and by looking at the 5G vision, it is empowering the IoT, as you could see here. It is empowering the wireless sensors network, and empowering smart home, smart grid, transportation, autonomous vehicles, VR, and online gaming, as well as medical centers and many others, as you could see here in the flow. So essentially, everything becoming interconnected, and with AI, everything becoming gradually smarter, and with the ecosystems, you're arriving to much richer and more satisfying type of solution. Traditionally, if you look at 4G, it's always giving you performance. So, for example, with LTE that we have today, we have latency, but the latency in around 40 milliseconds, and we have throughput speed about 100 megabit per second, and we have density. We have about 10,000 connection per kilometer square, and we also can support the performance or behavior activities with a high speed up to 350 kilometer per hour. But with 5G, this really look at the huge difference. So you're lowering your latency to 1 milliseconds. You're increasing your throughput 100-fold to 10 gigabit per second. You're increasing the density, the connections to a million connection per kilometer square. And you're also maintaining the services at a higher speed up to 500 kilometer an hour. These are typically what I call the technical performance of 5G, and that goes in line with what 4G compared to 3G compared to 2G and so on. But in addition, it is enabling now, as I mentioned before, uh, services across vertical markets. And that's a quick chart going back, comparing 5G that I just talked about versus 4G, focusing connection, wireless, and for voice and data, versus 3G versus 2G and 1G. You could see the speed, 100 megabit per second, going started with 2 megabit per second, and with 3G, 64 kilobit per second, and 2G, and so on. Now, if 5G is coming in, and as you could see here, the chart, the red line for 5G, if we look at by mid this decade, we're looking at 5G. It will not be over a sudden taking 100% of the market, meaning you will see 5G everywhere. It's basically actually to reach adoption of 20%. And 4G was still maintaining the higher share of the market, and in fact slightly sloping down and by 2025, but still dominant in terms of capturing 56% of the market will be 4G. And of course 3G will not die rapidly. 2G may slope down steeply, but not that much. So in other words, you will have a coexistence of multiple generation of technologies. So if we look again at 5G, because that's the future and that's really where you need to think about. And I took a different approach this time by classifying simply into three areas. 5G will enable three major categories of applications. One thing is dealing with the mobile broadband. So it will enhance mobile uh, broadband in terms of speed and accuracy and latency and so on. And the second one is the massive connectivities, especially in terms of IoT. And the third one is really where low latency come into play with mission critical, self-driving, industry automation, augmented reality, and so on. That's all require a much lower latency, whereas with massive connectivities, it's not as such critical in terms of latency. So you see that with the things like smart cities that you may have heard of, smart home buildings, and also the overall speed itself of downloading, for example, a video and so on takes much less time in 5G compared to 4G compared to 3G. Now, this is a picture that you may want to take a notice of because you cannot just jump and say, I want to have everything 5G today. And the answer no, because the features of 5G are gradually released through what is called the releases, 5G releases. So today we have released, we have a release 15, release 16 also was accepted mid this year. And next year we're focusing on release 17. So release 17 will start ushering in 2021, becoming more into 22 and beyond. But look at what could be done today. You cannot achieve 1 millisecond latency. That's really coming somewhere after 20 to 23. You can talk about 20 millisecond latency, which could be more acceptable as well as in the speeds. So now activities that you could think of, things could be dealing with the fixed wireless access, enhanced mobile broadband, um, a little bit on the public safety side and smart home. And as you move to next year, then yet it ushers more activities because now you are enabling much lower latency, higher speed, as well as increasing the reliability. So you can go to things like smart factories, real-time control. You can go to fleet and inventory management and tracking, and so on. And as you go move forward, and as latency becomes critical, then you could start ushering in applications that deal with the AR, VR, and healthcare, autonomous vehicles, and the like, as well as energy and utility management. So as you could see, every release unleash a number of features and capabilities that address some initially where it is needed most, which is the high dense urban, and where next in terms of suburban, and then selective rural area as the next step. The point I want to make here is that 5G has been launched. It is a reality. It exists right now in as a sub 6 gigahertz. Later on, will be ushered in as 6 gigahertz millimeter wave, as you could see here with the dark blue circles, and the map that you see here showing where adoptions and where deployment and have been launched in a number of areas in the last 6 months. So you see quite a bit of penetrations in all the continents actually. Some are much more denser than the other. If you look at Europe, it's vastly dense compared to other places. And there are means of tracking also how is 5G deployed. So you can look at it from pre-release deployment. So we have about 233 sites. You can look at it from limited availability. We have 10 sites, but commercially available in terms of 5G today, we have 15,000 plus sites that is using that 5G sort of enabled. And the circles here matching with the color show where it is in the world, and the number inside the circle, so the number of sites or cities or municipalities or counties that really using 5G at this point. And I took a chance of showing, okay, give me the area that we have in Austin as to who are the carriers. So certainly we see T-Mobile, AT&T, and in different places having commercial availability. There are three sites here in Austin that have commercial availabilities for 5G, and the surrounding also as you could see here, there are a number of installments of 5G enabled systems. So 5G, why I'm stressing that? Because it is unleash capabilities and features that will support all these types of market. I talked in that triangle, categories of markets, but you could see here now at the broadband level is everywhere. It's broadband access in dense areas, and the mobility, high-speed mobility, in the massive Internet of Things, as well as in the extreme real-time communications, lifeline communications, ultra reliable communication in healthcare, and broadcast like type of services. This is an interesting chart, again, similar to what I have shown earlier, showing latency on one side and bandwidth on the other side, but comparing also the 5G versus 4G. So 4G right now, what we have, and all the features and applications that we have, if we start looking at 5G, certainly on the low latency side, you have the autonomous vehicle driving, real-time gaming, and then as you move to the higher speed, then you're seeing multi-person video call, virtual reality, augmented reality, and so on. So that's just things that help you as a template, help you to see where do you want to focus your activities or your research or your prototype or functions or collaborations on in the future. Today, yes, there are some 5G devices that have been released. The most recent, a few weeks ago, is the iPhone 12. It comes in two flavors, the 12 Pro and 12 Pro Max. Pricing vary between $1,000 to $1,400, and it does come with 5G and sub-6 gigahertz as well as millimeter wave, and has the triple camera. It has advanced lidar for augmented reality, and has a huge amount of storage capability. We also have in the market Samsung with a few models, basically Galaxy S20, and you have three flavors of that at different price tag, up to $1,400 also competitive price, as well as you have LG V60 10 Q 5G, which is also 5G empowered, and have focusing more targeting low and mid bands, and also supporting Wi-Fi 5 as well as Wi-Fi 6. In other words, we have devices that can operate uh, as 5G. And if that's the case, then you start connecting that to a 5G network. Then you start operating one end to the other using 5G, and that could be in video streaming, um, also multiple connection of devices, as well as machine to machine type of communication, as I illustrated earlier. So let's take a couple of examples and see the difference. So, for example, we're all familiar with high definition video. Imagine if you have in your hand a 2 hour high definition video. If you try to download that with 3G, well, good luck, because essentially that will take you about 26 hours. You can fly from here maybe to Singapore, and then that by that time the video will be loaded and completed. But if you have 4G, we're talking really shrinking that down to about 6 minutes. If you contrast that to 5G, you are talking in seconds, less than 4 seconds. So now you could see the difference in terms of handling, especially video streaming and video applications and augmented reality, virtual realities, and so on, becomes quite powerful activities. So if you are in that domain and gaming and so on, streaming, well, that's a huge area of growth, and you could certainly capitalize on that. But there are also another huge other areas of innovations. Drone, for example, is becoming more and more popular for wide ways of applications. It could be used as a first aid, first responder, or emergency kit that can fly and deliver first aid type of equipment, or blood sample, or whatever is needed, or drugs. It could be also surveying things, a disastrous area. It could be used also to analyze the the soils and where areas that need special type of fertilizations It can also spray what is needed in a given square area. It could also use in terms of as an ambulance drone. So people, if they are stuck in a resort area, that's very hard to send any kind of ambulance to that resort area. You can dispatch a drone with instructions, and with the help of one person, be able to administer shocking the heart and things like that. And there are videos that actually related to that that you can Google it, as well as it could combat fire in a specific area that is hard to reach in a faster way. So that now you could see multiple areas of activities, unlimited thinking in terms of what can you do with the technology and devices. And the whole arena of autonomous vehicle and self-driving, we are just at the beginning of that. So we know that every car now has more and more sensors to make the driving easier, more straight, less risky in terms of blind spot, for example, detecting who's coming behind you that you can avoid, or as well as multiple cameras, front, sides, everywhere. And now we have connections with the infrastructure, with the street light, with the people on the road, with other objects, with other vehicles. So you can now have a constant communications to whole purpose again to increase safety. So if you are in love with the vehicle and automotive, there are, let's say, 5 levels of moving from highly dependent on the passengers to almost less dependent on a passenger on the driver to drive, similar to, let's say, on the flight, you put it in cruise control, except in that landing and takeoff, but you can run the rest as a remote cruise control. Except here, it's not the same thing as a flight, as an airplane. This is really much more complicated because you have all types of objects and constants and random and variables around you, left and right, whether it is solid object or mobile type of object or things that are shaking and so on. So it's much more difficult. And we would see today a whole huge revolutions in the whole health and wellness type of arena, as again, comparing 4G to 5G, we'll see beginning as we witness now with the pandemic, a lot of things are done with the telediagnostic and telemedicines. You can call the doctor, they establish a session, and they see what the symptoms you have. They may prescribe you, they send some drugs, they may wire right away the information to the pharmacy. The pharmacy can prepare it for you. All that while you are at home with the, and you could follow through with the doctor afterward. There are always wearables that maybe for heart conditions and things like that, that can always send the information and data and vital signs to the doctor or nurses to monitor the information. So it's started being used, and will continue to increase in terms of adoptions and coverage. So especially nowadays, and for remote access and telediagnostic and telehealth, as well as we move forward later on into telesurgery. So beside the home and having wearables and remote access and capabilities, certainly also the hospital are going through all types of transformations. And I mean, now we're witnessing uh, high demand on ICU beds and so on. So that's something. With the automations, you have account for what you have in ventilators, what's available, how can you locate it quickly in an instance, but also as people coming in, and you can administer um, um, treatment or administer what is needed with a high level of security, multiple levels of security, but having information on hand that could come from different sources, and having means of consultations with doctors and nurses and technicians and so on to ensure that the patients stay well taken care of. This is more intensified in the with the emergency rooms and things of that sort. We have some elements of that. You probably will see more increase in terms of intensity, but the first responder, whether it is ambulance or fire trucks or police, wherever there is a danger in some areas, for example, if it is a fire in some areas that's being reported, you now with the technology you could dispatch a drone that can collect a lot of information real time as quickly as possible and bring it back to the station, and you could so that you can prepare the right supplies and the right pressure, water pressure, or whatever is needed, the tube size, as well as equip what the truck with the fastest means of navigation to arrive to the site in the fastest possible way. But you have a clear understanding of the nature of the fire itself and the hazardous equipment around the fire itself, and be able to isolate that as well as build up a combat strategy to in order to save life quickly as well as minimize the any kind of losses. So we just visited now a number of areas that could be very exciting. Some could be of high interest to you. So I just wanted to whet your appetite as far as what's coming ahead. Certainly, if we dive deeper, if we take, let's say, city like Austin or city here like New York, they are putting a lot of investments in that infrastructure. So, for example, New York is putting $157 million in terms of enlarging the broadband infrastructure so that they can have a higher level of connectivities, enable higher speed connectivity, improve the first responder services, as well as the things that will require ultra low power in terms of consumptions. And they go through it with types of incubations, prototyping, piloting, and partnership. So these are stages that if you are not interested in the academic research, you can pursue innovative approach and as a startup uh, or, and by incubating your ideas and test it, have a prototype, piloting, and so on. So these will be the style or approach or the stages that you will go through. And certainly, uh, many areas now it open up in New York that will call for participation and contributions. Uh, Things, for example, food and waste, and water management, in terms of energy management and efficiency, IoT connectivities, mobility and logistic, real estate constructed, government technology, and civic technology. All of these are areas just in one city. So you can explore and see what Austin is offering if you wanted to, if you are here and you wanted to stay here and collaborate. There are a lot of entrepreneur and startups and small businesses that you connect with to get head starting. So the whole idea is that we're all aiming and building cluster and centers of intelligence around the industry, around the home, around the commercial activities and businesses, and collaborating with service provider, with the operations and distributions and the market activities. Again, the whole purpose of why are we doing all that? Again, to improve quality of life and to enrich the our personal experience, and of course improve the efficiency, overall business efficiency, and so on. Sorry for that. Now this is really bring it to the last point here I wanted to stress, and that's really this is all going to unleash opportunities, and whether you like it, pursue it in research aspects, or whether you want to do pursue it in terms of startups. So in the research aspect, I give a few ideas here. There's quite a bit of university technical research, and they typically post various areas that solicit participation and contributions. Examples could be IoT advanced sensors. That's one area. The whole business of tattooing is really growing so fast. Nanotechnology, internal intelligent material. These are all future areas of interest. I talked about edge computing and intelligent edge, architecture revolution empowered by AI, ML. You could, if you are engineers and wanted to focus a lot on the radio side of it or the networking side of it, and the core network, then this is also interesting area of research. Cloud applications, big data, deep learning, and so on. That's another big area of research. Any, you can move deeper into any particular aspects of it, and especially also industry outreach. This is really a good collaborations. I use this actually approach in terms of, for example, connecting with the Texas State University. I built up a program for senior design students. Each program is about 8 months, and it is credited. And each project is about 4 students with a mentor as well as a teacher as well as a sponsor. So it's connecting, first of all, students to industry. It also connect them to IoT and understanding the technology, how it could be used, not only the IoT aspects of it, but also the communication and the cloud and the services, and through hands-on and through building prototype. So every project, it starts with the technology and positioning, what area you want to serve, and how are you improving the certain aspect of the community. And the second term is really getting the acquiring the platform and start building the uh, what is sensors needed, how you connect it, how you start programming it, and demonstrate various type of functional prototype into it. This has been done 3 times, and students have a wide interest in terms of pursuing that beyond the prototype, and we try to help them on that. So that could be an area that you could teach, you could administer, you could be part of, etc. If you are in the you're not really wanted to carry out more on the academic side, but you want to jump into industry, or want to be a startup, you want to have a small business or contribute to industry leaders like Amazon and Google and Facebook and so on, then there are a lot of approaches to it. How, first of all, you have to think of what I outline as a landscape and pick up an area of interest that could make a difference, and picture of how you are going to develop and demonstrate a functional, high level functional prototype as a trial. And in some cases, if the project is quite large, you may collaborate with other people to work together. Or if it needs multiple equipment from different sources, you may want to collaborate with the different vendors and to put things together. And you may want to also test it with some lead customers for a trial. And as you started going through that approach, then you start materializing and realizing those ideas, and you start now acquiring funding so that you can bring those ideas into product for distribution or services. But other things to watch for, which is really applying best of practice. In your approach, you always have to look at the total picture. And remember, I talked at the beginning about point solution. Point solution really is only an entry point to prove an idea. But the essence is not to deliver a point solution, is really how to deliver multi-point or collaborative solutions in a context of an ecosystem. And then that also may require collaboration because, as I said, not a single player can do all the whole job. So you need to work out with multiple players. Plan big, but start small. Ensure security is part of your product design from the beginning, and leverage open source to speed up your development. There's a lot of open source material exists nowadays, and work demonstrating quantifiable and measurable results. Many people will say, "Oh, it's nice, but I don't know the usefulness, and I don't know what benefit this will bring me." So I have to think of some ways of quantifying the benefits that this is generating. Be resourceful in terms of there are tons of information on the website that you can tap on, or talking with experts and so on. And not to forget to identify, for any situation there always be risk, so identify always potential risk, but more important, how you're going to mitigate that risk. And finally, I'll end up with one example use case, and that's actually a personal example. This is I was called upon in the early stage of my career to lead efforts at the corporate level to build up a network management for a global carrier. And I was given there's a consist of various satellite and cable stations, and we have equipment from about 70 vendors that we need to tap into. So that was one area that really took a lot of effort. But the other area that, as you could think that as the sensing layer, then as we started getting the data and start looking at it, there are certain alarms come in, there are fault coming in. We need to analyze that. We need to localize it. We need to look at the configurations. We need to modify the configurations. We need to look at the performance of what the impact this could have in terms of traffic and so on. So that layer is a control layer, or now you could call it edge computing, is really playing that role in that sense. And then the third one is really getting that all that information now that you manage those layers. You need to look at it from a higher level perspective, which is the overall network itself in terms of services, quality of service, guarantees, and SLA agreements, and so on. So that becomes viewing information at the aggregate level, so that you could make a greater sense and predictivity, and doing things like maybe rerouting and so on. So that an area that it's a multi-year, multi-million dollars project that was implemented. Um, but knowing what we had at the time versus what if we want to do it again, I certainly want to leverage the technology. And here are some areas that are we, if your area is just in management of telecom, or this is just a purely an example. So if, certainly in the area of sensing, you can apply AI to localize fault and look at the impact on traffic, impact on customers, impact on revenue, impact on priority of service. You can have AI-based network configuration. So you heard the things about SDN, software defined network, and doing things like rerouting and discovery and expansion. And of course, you can have assisted AI for quality of service and network performance analysis. Also look at the equipment side of it, and facilities and reliability and predictive maintenance. You can look at AI also for other things like contract management, also detecting fraud in billing, for example, other means, and use blockchain, and overall introduce much rigid type of intelligent type of communications. So as you could see, we just with one area. Each one of these area could be a research by itself, as well as could be huge development. And here just was an example to support what I'm going to say. If anyone pursue that area, I wanted to show that these things are growing also in the market. So they are huge market opportunity for the next few years. So with that, I conclude with one comment, one takeaways that certainly we witness technology have a greater impact in overall market. It is in the heart of many type of systems and vertical markets, and certainly it create unlimited opportunities for innovations and collaborations. So let's leverage that era that we live in. It's such a unique opportunities, and see what really your heart is for, and pursue your dreams. So I wish you all the best, and thank you so much for your attention. And here is the actually book that I mentioned before, Collaborative IoT. It's also published by Wiley, but also if you are IEEE member, you have a number of discounts that you could, if you are interested in the book itself. So with that, I stop here and ask Rachel for um, taking it over.
Thank you so much, Fawzi. It was very informative and an interesting talk. I'm sure all of us learned a lot, especially about 5G, IoTs, and their impact on smart cities. I had a question about like the security part of it. So when we increase a lot more connectivity, aren't we giving room for even more security risks than we have right now?
Absolutely, especially at the sensor side. Sensors is the most weakest area in terms of it doesn't really have a such security because of the cost. I mean, sensors by themselves are very, very cheap. And even if to add 5 cents for security algorithm and so on, it is an overhead. and many companies have really refused to do that. But you could group sensors into what's called today microcontroller. It is a smaller area, but you could certainly embed security algorithm in it or security engine in it and watch over these sensors, so it becomes like a secure a gate for these sensors. In 5G, there is a heavy focus on also insecurity. There's an area I didn't touch upon called network slicing. It's basically isolating and slice the network into pieces, but every piece will have things like KPI, key performance indicators, and security as one of the key characteristic of that, as well as quality of service. And this way you could achieve end-to-end quality of service, but also end-to-end security. So 5G is coming up with a whole suite of security and QoS end-to-end and ecosystem type of solution. But as we transition to that, we certainly need to equip ourselves and look at all the weak links. And these are the subject areas that need to be trapped and need to be located and need to these becoming areas of risk that need to be mitigated.
Thank you so much, Fawzi. We have a question in the chat. I can read it out for you. So it's from Dimitri. Thank you for the amazing and visionary talk. The question is, Dimitri says that as we move from 3G to 4G to 5G upgrades, and it seems like it improves similarly to Moore's law. Is that correct? And on a side note, number of bits per second, or is there a technology that can completely?
So you were cut off. I get bits and pieces of your question.
Oh,
Sorry. I don't know if it's my end or your end, but I only had heard bits and pieces of it. If you could repeat it.
sure. I can repeat it. So the main thing is we have upgrades from 3G, 4G, 5G, which seems to be similar to Moore's law for semiconductors, number of transistors increasing with every 2 years, doubling every 2 years. And in a similar concept, what is it 5G and it's becoming 6G or 7G? Is it just increasing the number of bits per second, or is there a technology that can disrupt the trend?
Great question. And essentially, it is really taking a different direction than Moore's law, and in many there are a lot of theories. As you know, Moore's law is also transforming into different different means. You get the geometric Moore's law, and then you get I don't know, the algorithmic Moore's law. You get law of laws, and so on. There are about three major areas that Moore's law is going through by accommodating the environment to be able to maintain some level of density or lowering the real estate of system on a chip by using multiple processors and multiple ecosystem and SoC. But in contrast, I mean, 5G is really taking different dimensions in terms of certainly it is leveraging the the um, the miniaturizations of the silicon. That's no question about it, and by that it's able to make condense a lot of transistors in a smaller area, and that's really where it provide huge intelligence in just a smaller area, and that's making possible to build up a smart network and consequently building up what is called later on down the road smart cities. But the so 4G was really primarily focused on the performance aspects of it. 5G is the one that's saying that I will really take, beside the fact that I'm going to improve in the performance, I'm going also to affect the realizations of services and systems and networks, as I highlighted many vertical markets. 5G is the only one that has really addressed that. 6G will take it a step further, saying that now we we have added machines, we have added objects through the IoT. Now we're adding machine-to-machine connectivities. Before we could say sensors connecting to the network or to the uh, IoT or to the edge computing and so on. But with 5G, you can have machine talking to each other. So that's why you can have autonomous vehicle can talk to each other and so on. And 6G, it's actually adding another dimension, which is the space. So now you will adding the satellite will be added to it. Non-terrestrial will be by all different shapes, gestures will be added to it. So it's really moving to a wholesome type of approach and maintaining that level in terms of lower latency, critical application, and so on, but and expanding the scope and the scalability of the applications. So it's really taking a different route and different direction. The whole purpose again is to enrich our environment to be intelligence. So if you go to the doctor today, they look at your symptoms and they will give you prescription, and that's the end of it. If you look at 5G and beyond, they will not just do that. It's actually going to identify the root cause, what really caused that symptoms, and analyze that to your genes, DNA level, analyze to your habits of eating, analyze to the exercise, analyze to many things, and then start prescribing a personalized type service. So that's really where five at the end of 5G, that's what it will lead to, and 6G will continue to add to it by adding gestures and other means to accommodate that. So that's another vast
Thank you so much.
unleashed opportunities.
Thank you so much, Fawzi. Do we have any more questions? I know we are a little late. It's almost 7:10 right now. Yeah, if you have any questions, please feel free to speak up or put it in the chat. Yeah.
Or people can send an email. I'll be happy to respond to.
Sure. Thank you so much, Fawzi.
Welcome.
Yeah, I guess that's all the questions we have for now. Thank you so much. It was a very wonderful talk, a very interesting, informative. We all learned a lot, and it was so nice to host you today. Thank you so much.
Thank you so much, Rachel and Dimitri, and all these section. And I'll be happy to anyhow come again and address other means. So I'm happy to have that opportunity. Appreciate it.